So, task queues. We're going to do Python, we're going to talk a bit about Ruby, and then we're going to go to PHP, kind of build our own. But first, kind of like, what is a task queue, right? And I have this kind of ridiculous explanation, like a system for parallel execution of discrete tests and a non-blocking test. Basically parallel in the sense that you can run as many of these workers as you want to like take care of tasks at the same time. Discrete in the sense that you provide it as much data as it needs to complete tasks. And non-blocking, so it can kind of tie together, and it doesn't need to have one particular task precede another one. There's different implementations. Celery is one, rescue is another one. Celery is in Python, rescue is Ruby, but you can grow your own very easily. It's really not that hard. There's three parts to task queue, and I'll just go over this real quick. If you listen to James talk about RabbitMQ, this is literally like the exact same thing. Brokers, middleman, holds the tasks, maintains the list, kind of a FIFO, first in, first out. RabbitMQ is the underlying stuff there. That's like the most common broker. Pyramid's another one. People use Redis, and people have been known to use things like a database or a SQL server, which is not as good, but people have used it, myself included. Producers are the code that basically places the tasks in the queue. Pretty simple, and usually this is just your application code. It sits right next to you generating HTML or making database calls or whatever, right? Consumer is also called the worker. It takes the tasks from the queues and does them. Usually this is daemon under supervision, but the producers put things into the broker, the consumer takes things out of the broker and does them, right? So let's get a little scenario, and this will kind of, because when I started with task queues, I was like, why is this such like a thing? Why do people are enamored with this? Cron tab works great, right? So here's an example. You post, like basically Twitter. You post a message that triggers an email to your friends, right? Here's a little code that would do this. This is a Django view, and it's really, really simple. Basically, gets the user, finds a message from a post, saves it, and then here's the dirty bit of code that we're going to run into some problems with. This just loops over all your friends and sends them an email, which is a pretty standard sort of thing. The problem is it works good for like 0 to 6 friends, right? It doesn't take long to send an email or do any sort of thing like that, especially when it's small. But what happens if you're, Mr. Romantic Comedy like Ashton Kutcher on this? You have hundreds of thousands or millions of friends waiting, to hear about it. You can't make them sit there while you send a couple million emails. You usually never get a response. Basically, it's tied in that response, request response. So the first bad idea is you just ignore it, right? You just kind of business as usual, and people just wait, right? But they're important, so that's a bad idea. Bad idea two, Ajax, right? Well, let's just return the page really fast, and then include some JS code that'll call another script that'll send the email. Slightly better, except you're still you have a possibility of getting duplicate calls, where you kick that off twice if they hit refresh or something. And also, if it takes 5 or 10 minutes to complete a task, that's Apache sitting there doing nothing, timing out because you have this massive task sitting behind it. So that's not really the proper way. And then, of course, bad idea number 3, which I've been fond of, is make an email friends table with user ID and message column, and cron over that every 5 to 10 minutes. Backlogs are going to destroy you in this case, because as soon as you get too many tasks that you can handle in that interval, it's going to start stacking up, right? And then you're going to say, okay, well, I'll do it less often, and pretty soon you can't do any, because this is not parallel, it's serial, it's one after another. So that's bad. So the solution is queues. Big surprise, right? So you take that task that potentially emails thousands of users, and you put it in a queue to be dealt with later. And then you can return the response to the HTML, redirect the user, do whatever you need to, standard, because they don't need to wait for those emails to go out. It kind of is divorced from them. So this is what you might do. And this is, again, using Django kind of view and using something like Celery. Basically, all you're doing is this function. It's a discrete function where it has user ID and message. That's really all you need to perform this. You can find all the users by grabbing, or all the friends by grabbing the user out of the database and looping over them and sending all the message. I'll talk a little bit about this little task decorator here in a second. But basically, that's the gist of the actual task. And then down here, you you have something, a little bit of sugar to run your tasks. We just call delay on it, and this is using accelerate, so it gives you this kind of ability to do that. Task is basically this decorator up here. In Python, it just wraps a function with another function. So it does a bunch of fancy stuff behind the scenes, converts it to like a class, and adds some extra methods, and that's what the delay method is. It's basically this ability to call this task. It doesn't actually run the code in it in that response cycle. All it's going to do is throw it into the queue, right? And then it's going to wait for some sort of worker to come along and get it. Since we're here, I have two really quick rules. Adding a task to a queue should be faster than performing the task itself. That's kind of a no-brainer. But you can't go a little too far down the line of turning things into tasks when they probably shouldn't be. You're introducing some overhead here. So not everything is like that. And especially if it happens to be like, oh, I need the results to respond to the user, right? Like if you need it, it's like calling a database. Well, you need that information to render the HTML. That wouldn't be a good task, right? Rule number 2 would be you got to consume tasks faster than you produce them, right? If you're adding 500 tasks to the queue every minute, and your workers are only able to chew through 400 a minute, every minute you're going to be adding 100 extra tasks that are just building up a backlog. It's really simple to scale this out in this situation. You just spin up some extra workers, and they add some more overhead, and you can chew through jobs quicker. So that's kind of the rule 1 and rule 2 of the way that the task queues, like you generally, if you follow these 2 rules, you're going to be pretty good as far as how they interact. There are different queue libraries, and we talked about Celery, which has a bunch of fancy, wonderful stuff in it. We use it in Zapier because we use Python. It lets you use different brokers like RabbitMQ. You can do Redis. You can use Gearman. I think you can use even a database table as well. So you can kind of like mold it to fit whatever your stack is. And then Rescue, which is a Ruby version of that, it only really uses Celery, but I want to show you that same example in Ruby. And of course, all this code, I should mention, like this code and the slides are up. I sent an email to the list, so you can hop on there and take a quick look at it. It's the same sort of thing, right? The task exists in this class. Perform is the standard kind of method name that Rescue uses. It finds the user, loops over all the users, and emails them, right? And the view down here is the same sort of thing. Use Rescue, you add to the queue, the message send task, and here's the parameters that go with it, the arguments that go with it. Of course, that code is not going to actually perform the stuff, it's just going to throw it to the queue. And then behind all this, and we're going to build our own, behind all of that, there's workers running. And they work, they're very similar to what you're used to if you have a web server running or a database or something. They exist in the background, and they're just kind of running all the time. And that's really the only thing you need to add for that is this broker, right? It might be RabbitMQ or Redis or something like that, as well as these workers. And if you already happen to be using Redis, well, then it's even simpler. If you happen to be using if you want to do it like a database type one, you can also do that. I don't recommend it, but it's better to use these solutions that are kind of designed for it. We use RabbitMQ with Celery, and it works really, really well. So we're going to build our own. And we're going to do it with Redis and PHP in less than 50 lines of code, because these things are really, really simple. We're not including the test code itself. Quick Redis aside, how many people use Redis? I'm just curious. So Redis is a key value store. It's basically all in memory. And values can be strings, blobs, lists, or hashes. Keys themselves are just strings, really simple. And what we'll use is lists. And we'll use rpush, which is add something to the end of a list, and lpop, which takes something out of the front of the list. And that's the only part of Redis we'll use. Redis is great for all kinds of different stuff, but that's all we're going to use here. So the first thing that we're going to want to do is create a task runner. And this is really, really simple. It's basically just a task class with various methods named after each task. Right? So you might have a task called email friends, or generate PDF, or whatever, right? And then each method is going to accept an array of parents. And in this case, we'll kind of get into the detail of how that's going to work. But basically, you need to get data into the then that's what the parents is going to be. It's going to contain all that metadata needed to run that task, which in our earlier example is user ID, and message. So this is the tasks function, and this is PHP, of course. Really simple tasks class, a function called email friends, takes parents, parents spits out so you can see we're grabbing the stuff from parents. Actually, and this is an object. That's just the way that PHP handles, by default handles JSON, which is what we're going to use to serialize this. We would get the data from the database, but in this case we're just going to stick up an array there. And then for each of the friends, we're going to echo a fake email, which would be a real email. And that's all you need for a task like run, the actual code. And if you wanted to add more, you could simply add another public function called generate PDF, or you add another public function called whatever you want to call it. The next thing you want to do is create the worker. And the worker, again, is the thing that's going to be consuming these things. And you're going to, it basically, it's an infinite loop. It just keeps looping, looking for tasks sitting in the queue. In this case, we're using a variant of left pop that's blocking. It's called BL pop for Redis. That basically says, instead of returning nil, if there's nothing in that, that list or that queue, it's just going to sit there, and it's going to wait until it gets something. So instead of your thing just spinning insanely, making crazy calls to Redis, it's going to open up one connection, wait for something to come in. And then whenever it gets that information, it's going to run the right method on the task object. That's really all it's going to do. You see, I bring this stuff in, and of course I'm setting up Redis, and I have my tasks class up there. Initialize it while true. Here's the bit that's actually going to grab the data from Redis. And in queue, I have just the name of the queue. It's like string. I think I called it like PHQ or something. It's going to grab that from the queue. It's going to decode it, give us the object back, and then the object, we need to know what task name it wants us to run, and also need to know the params that the task is going to need. So we have the method, we have the params, and this is the somewhat bizarre way to call a function or a method on a class PHP called callUserFunction, which makes no sense, but we are dealing with PHP, so it's a little crazy. Task method passing in the params, right? And I mean, it's pretty terse. I mean, it's pretty simple. Now we need to run it. This is really simple. You run the work with PHP. That'll take up your terminal. It'll just sit there. Well, it has a locking Redis pop just sitting there. And now we're going to actually add a task to it. We're going to do a quick handy function here called add task. That's going to do the things like serialize the stuff to JSON, and then it's going to push it into the queue. So here it is. We're going to include Redis again, which sets up Redis in the queue. We're going to grab the data that we pass in. We're going to pass in the task name. In this case, it would be email friends. Params would be an array of some sort, which would include all the data you need to actually run that task, right? The discrete data that you need. We're going to encode it in this array, encode it as JSON, and then we're going to push it into the queue. We're going to push the JSON into the queue. And then this is kind of the example of the API that you have, right? Add task, email friends. Here's the data that the task wants in order to run. And then the last step, whenever you have this, you have your worker running, you added your task to the queue. And this is more about like production, right? You need to keep track of your worker, right? Because you don't want to just run it while you're logged into SSH into your server. You need it to keep running after you leave. And you also need to be able to spin up extra guys if you need to, extra workers. Then you can use stuff like supervisor, which is written in Python, that of course can monitor anything, and God, which is written in Ruby. But you can use all kinds of stuff. Initd, they're pretty standard. Those are two really easy ones. And yeah, that's what you use to run it and monitor it. A few things that are missing, and I'm going to spend a little time on this, because a lot of what Celery, Rescue, and those guys do is provide all this extra stuff around it. Ours is really, really simple. You can add more tasks to it. It's very simple to add more tasks. You can call it. We have that manual function for adding the task itself. But it doesn't do a lot of the other things that you might get with the messaging queue, like RabbitMQ lets you do lots of routing, lets you do clustering, lets you do all kinds of things. Whereas our example is very cut and dry, simple. Good example, Celery will let you store return results. In our example, if you wanted to store return results that you get from something, you'd have to either dump it into a cache key or into a database to get it back later, right? If it was, calculate or generate the last 12 months of sales reports as a Excel or CSV, you need to save that to the database, or well, save it to your file system somewhere. It clearly isn't going to handle it for you. So seems pretty obvious, but the nice thing about Celery or Rescue or something is it'll give you UI IDs like that, and then whenever you're ready to get the results back, you can just call it again and get the results. And they'll sit there waiting until you ask for it back. It doesn't handle errors. If you hit an exception or error, your code freaks out for whatever reason, you're going to kill the worker, right? Which is not good. So you want to build in some magical way to catch those exceptions and probably log them. You don't want them to just silently crash everything or be ignored. Routing tasks is big. One thing that we do a lot with Zapier is we have different queues for different types of tasks that we're performing. You might have, in our case, we have lots of read, we have write queues, we have all kinds of different queues that exist because what happens within those queues are a little bit specialized, right? A good example might be, what if you were computing some sort of sequence of a gene or something? That would be probably really, really high, memory to do that because you got to load all this data in and do a calculation. Well, you might want that to go to a different server. You don't want that to go to your high CPU, low memory EC2 instance. You'd rather go to your high memory, low CPU instance. So you can kind of switch up where your tasks are going and which servers are going to run that. And Celery, Rescue, things like that give you all those facilities for free. You can say, RabbitMQ, I want to go to that server, this server. And they'll automatically be dispatched wherever they need to go. It doesn't degrade gracefully whenever it has problems or runs into sort of situations that it can't do stuff. A good example is if you didn't want to use Redis and you wanted to use something else, well, there's no abstraction there. You can't just switch one out for the other like you could with Celery or something like that. Or there's other examples of software that does this or packages that do this. So you end up rewriting a bunch of stuff. And it doesn't log activity, so you don't know how many tasks are going through your system. You don't get a chance to peek at them, right? They just kind of happen. So whenever you use those other packages, you do get a lot more power than the things that it can do. I'm trying to think. Generally what we do at Zapier, we don't store any return results. We handle all that stuff ourselves. Errors are tracked through another system. Tasks are routed, like we said. We use RabbitMQ. We have the logging thing. There's a nice admin. That's one nice thing about using something like Django or even Rails stuff. Give you a lot of that stuff for free, so you can just log in and see how things are going. So we do use those a lot, and they're great to have. But if you're just doing something as simple as okay, this is going to be kind of a task that takes a little too long, it's much, much better than running it in the request response cycle. It's good to kick it off into something else. And I think that's really about all I wanted to talk about. The code for what we did up here does exist on a GitHub repo, which does work. What it requires is you have to have Redis 2, I think above Redis 2.0. I think Redis is at 2.4 right now. In order to do the blocking, let it pop. And you also need the library that actually sets up Redis. You'll need Python 5.3, I think. So if you're trying to run that and you run into issues, that's probably why. So let's see. That is the end. Are there any questions while I'm standing up here? We have task queues.
I guess because when you're sending out a lot of emails and you get a lot of errors saying this account no longer exists, it'd be very nice to scrub that from to symbols.
Email. There's a whole messy science behind sending emails that running like a task queue is certainly not going to solve. Especially balanced emails is a good example. Malformatted addresses, all kinds of stuff. If you're doing that, I'd recommend a service like Postmark or SendGrid that'll track that stuff for you. And it's the same thing. You don't want to make 500,000 API calls to SendGrid or in your request cycle. So you still want to do it in something like a task queue.
You said if a worker gets overloaded with tasks, like a solution would be to create more workers. I'm still not entirely sure how that works.
So an example is whenever I have that code that, in this case, we have our worker, right? So this is the entire worker right here, and you can run multiple instances of this. And so you could have a dozen of these workers all sitting watching the queue. So when you add maybe 120 tasks to the queue, each of them will just grab one at a time, pull them off, and perform them. So if you want to spin up new workers, you literally could, just as simple as opening up like a new terminal and saying PHP worker.php, and it would spin up another server because it would start that up, start doing the loop, start watching. And you need a way to like kind of automate that so you don't actually have to log in to do that. It's like, oh, the queue isn't being taken care of in the proper amount of time, increase the number of workers, or spin up another server that's the same thing. So, does that help?
A little bit, but if they were all doing, say, the same task at the same time, wouldn't they still run into problems?
Like duplicate, like two of them get the same task?
Yeah. Well, not duplicates, but same task with different parameters or something.
Well, the idea is each of these are their own discrete thing, right? And they're all hopefully running the same code unless you left it running after you updated it or something. So generally the idea, and I don't know if I'm answering the question properly. Generally the idea is whenever you're doing a blocking pop for Redis, it's not going to give that value to more than one client that's listening for it. It's going to give it to one particular worker, and then the next one's going to go to the next one, and they'll just kind of round robin around. So actually that's one problem why you might not want to do a database table, is you could have situations where the locks don't catch right, and then you would have problems. So that's why using something like a database can be very problematic. Because you could have two workers that look for it at the exact same time, pull it down, and they both try to delete it. Well, one's going to delete it, and the other one's not going to be able to delete it, so then you have sort of an error that you have to worry about. So yeah, that's certainly a problem. If you're using something like Redis that's all in memory, that's designed to not do that sort of thing, RabbitMQ is also designed, you won't have to worry about that, because they won't hand your message out twice. It'll just happen once. Does that help?
Yeah.
Okay, cool. Okay.
So in your Django example, you showed the worker was a function within your Django app.
Yeah.
And I'm pretty sure with Celery you could do that, or you could probably have it running on a different server.
So the cool thing about how Celery works, and most of these applications work, and in our example, we had a different file that had your tasks, right, that you'd have to, you wouldn't have to actually import that, you would just need to add the task somehow to the queue. All it really needs is the name of the task and the parameters, and you don't need access to the code to do that. Celery works a little bit different, where the code that runs your application is generally this, for your HTTP server, is generally the same code that is also behind the workers. So the difference is the Celery workers don't respond to HTTP requests, right, and the HTTP server is not going to respond to tasks, but they use the same code. And what it does is serialize those tasks themselves and then go into your code and grab them for you. So you can intermix with something like Celery, where you write your task anywhere you want it to go, and the worker is going to be running the same code that you're writing. So.
Yeah, and I see where that would be really nice because you have access to your kind of data objects that you've already modeled out in Django.
Yeah,
but
exactly.
I wonder if you guys have ran into a situation where that doesn't really cut it, because you don't want to start up a new web server if you're doing video transcoding or even sending emails. Maybe you don't want to have to fire up a web server just to.
Generally the idea is you would plan for enough capacity to, on average, clear out the queue. So there can be times where you spike up, and maybe you would say, well, maybe we should add another server. But generally this server would be running continuously anyways, and if there's no task for it to do, it just sits there waiting for tasks to come on. But you can spin up another one if you wanted to, but otherwise you just kind of design, plan for.
So you run all Django servers. You don't have any Celery workers that are just like a Python script.
I wish I had a good way to explain this. It's the same code base.
Yeah.
Like we pull from the same repo for the worker server and the HTTP server. So it's the same code base. So if you update it one, it goes to both. So we do have multiple servers out there. We maybe have a couple doing HTTP and a couple doing workers. But the thing is, you can scale them separately. You can add another HTTP worker behind a load balancer. You're good to go there. It's not going to affect how many tasks you can perform in a certain amount of time. And that's generally the same idea. In this case, you probably would have your PHP worker.php would be on a different server. It's generally the idea behind it. That way, whenever you actually are backed up with tasks, people can still go to your site, use it, they can add more tasks to the queue. And that's not going to hurt anything because it's just sitting in memory. It's not like using up CPU resources, right? It's just kind of sitting there waiting to be taken care of.
And like, I guess the answer to this might be the routing thing you were talking about, but like if you did have a specialized task like video transcoding and you didn't want to have to have that executable on your web servers, that's where you get into routing and saying only send this task to...
Yeah, so like if there's some sort of like C library dependencies, like yeah, you could certainly install them only on like video server 3 or something.
Yeah.
You know what I mean? Or worker server 3, whatever you want to do. And then you route all of them to that particular one. And none of the other workers would grab it, because they grab all the other tasks that come through, but not the video ones.
Nice.
So you could certainly do that. And you can specialize it anyway, because at a certain point, like you're serializing data into the queue, and then you're just taking it back out and doing something with it. So you can, there's an infinite number of ways that you can handle it. You can write totally different code that's divorced from your app. You can do all kinds of different things. Because at a certain point, it's just serialized. It's just a bunch of text. Here's some text that says you need to do this task. It just so happens that the way that Celery and those guys do it is lump all the code together. So, any other questions? Yeah.
Does Redis write anything to disk, or is it only memory?
It's predominantly memory, but you can have it like persist to disk. And generally, how they let you, they have a really nice way that you can set it up to persist. You can set it after X many keys have been changed or moved, it'll persist it. Or like, the greater of either those keys or like 5 minutes has passed since the last time or whatever, or just never do it. And as soon as like the server gets restarted, to lose everything. So yeah, you can let Redis persist the disk. And it's the same thing with Rabbit as well. You can have Rabbit persist.
I use Redis and I was wondering about the danger of a server crash where we had a bunch of things in the queue.
Right.
You could potentially lose a couple hundred tasks.
Yeah, you could. Yeah, you definitely could. Probably a better solution than having like Redis queue do it, because Redis is not really designed to like persist the disk so much that you have kind of real time, failover or something. You're probably better suited for using something like Rabbit MQ, which will stream into disk live for you. You can turn it off if you want, but by default they will. So you can kill your Rabbit server, spin it back up, and you can look at the queue and it has all the same tasks that it had a second ago. So that, generally, Rabbit is a little more complicated. You have to set up like virtual hosts and users, but it's not any more complicated than Postgres or MySQL or something. It's very similar. Redis is like dead simple. Just like you install like Redis, you run it, and you're done. You're like, really? Like there's Redis is like so simple. Everyone should use Redis. I love Redis so much. It's my man crush. So yeah, you gotta use Redis. But yeah, Rabbit MQ generally is what you use for persisting. And James knows a lot about that as well. Probably a lot more than we do. But yeah. Other questions?
Thanks, Brian. I guess there probably aren't really any more announcements, but the next meetup will be on June 20th, third Wednesday of June. So, yeah, thanks for